So, in this revision of quantum mechanics, we are just going to revise some important topic that is from the approximation method. And at least 2 to 3 questions will surely come from this part, and all are more or less from the part C part. That means you have 5 marks question. So you have to prepare this part very intelligently, and fortunately there are not very uh, not there are a lot of formulas and concepts are there. There are some algorithm you have to follow. Concepts are always there, but they are not directly used as a first principle. You have to use basic formula and then you have to go for this. So I will start with the non-degenerate perturbation, and then we will go for degenerate, then time dependent, then WKV, and then variational principle. So let's try to go for each and every step. So first is time dependent perturbation. Sorry, time independent perturbation. So if you have time independent perturbation, you have to work on mainly three different formula. And what you have psi is equal to pi n plus lambda psi n1 and higher order term. And similarly, you have En is equal to En0 plus lambda En1 and plus lambda square En2. And we all know that En1 is first order energy correction, En2 is second order energy correction or energy correction up to order of lambda, and psi n1 is the wave function correction in up to order of lambda. So what is idea? You have two part of Hamiltonian. The first part of Hamiltonian is original Hamiltonian, and the second part is all about perturbed Hamiltonian, which can be written like lambda w. And we know the eigenvalue and eigenfunction of original Hamiltonian. So this can be written as something like this. And these are well-known system, and you have solved all this type of problem. So what you have to do, you have, and obviously in the examination, you need not to solve this thing. You know all these things. Suppose particle in box, harmonic oscillator, hydrogen atom, Dirac delta function, only these 4 type of system we have solved, and we will just try to disturb this system and we have to calculate this one. So in the examination, they will ask either to calculate En1 or En2 or psi n1. So what will be your En1? Bataiye, what is your En1? On the nth state, En1 means first order correction on nth state. So what you have to do? You have to just calculate phi n w phi n. And this is nothing but the expectation value. This is nothing but the expectation value of your perturbed term on phi n state. So if you know phi n, the W will be given into exam. You have to just calculate this particular thing. So in every examination, you have to be very much careful how to do this calculation. Whether you have to use the matrix method, where you have to use the operator method, or you have to use the functional method. So in general, if you will go for a particle in box, hydrogen atom, you have to go for functional method. That means you have to just go for integration method and you have to solve it. And for the harmonic oscillator, you have to go for operator method. And in the harmonic oscillator, the beautiful operator x is equal to h cut upon 2m omega, and that value is equal to a plus a dagger. So you can use this particular thing, and you can use this particular x, and then you can write your phi n in, and you can write your phi n as your number operator. So this is one thing you have to always take care. So whatever we have learned in our earlier classes, that you have to know what is your phi n for all different type of system. But in general, when you are calculating the phi n, read the potential part carefully. What is the actual parameter and how you can write it? Because maybe in the class you have done this particular particle in box for minus a by 2 to plus a by 2. But in the examination, they will give you that thing from minus a to plus a. So accordingly, you have to write this particular wave function. So this is very interesting and this is very important. Most of the people are doing this blunder that they are just using the wrong wave function. Suppose in the examination, you have done all this thing for harmonic oscillator for omega frequency, but they have just asked you some new frequency, then how your wave function is going to change. So first thing you have to always go for that, and please just try to do practice, and we have already done this thing. Try to do practice. What will be expectation value of x? What will be expectation value of x square? What will be expectation value of Dirac delta x and delta function? These type of function, what will be expectation value of something sine kx? Okay, sine kx, what will be expectation value of cos kx, where k is some, or you can write it alpha x, alpha x. So these type of calculation on the some wave function you have to practice, because there may be perturbation linear, there may be perturbation parabolic, there may be perturbation of Dirac delta function, there may be perturbation of sine alpha x, there may be perturbation of cos alpha x, even you can go for sine hyperbolic, cos hyperbolic. Just try to find the expectation value of all these function, at least for the ground state of each and everything. But yes, if you are going for the harmonic oscillator, this thing can be only solved with the function method, okay, with the solution of Schrodinger wave equation. But here you can use the operator method, all this thing. But you have to also remember the basic property of this particular thing. Suppose your perturbation is antisymmetric about the center of your potential, then how you will do this integration? How you will do this calculation? Suppose in the examination, in the particle in box, they have given you this type of potential. So this will be minus V naught, this will be V naught, and this is D distance. This has also D distance. So how you will go for this type of potential? This type of potential is very interesting and very important. So you have to do this calculation in a very nice way. You have to calculate this point, you have to calculate this point, and then you have to go. So the symmetric is very important to solve this type of time independent perturbation, either for your degenerate or non-degenerate path. So you can just prepare this type of potential. So what will be happen to this type of perturbation is there? क्या होगा अगर ये कुछ अपने, suppose this is your center and this is your antisymmetric, then what will happen? Exactly same height is there, exactly same width is there, but this is negative side, this is positive side. What will be your first order correction? What will be your first order correction? इस तरह के सिस्टम में क्या होगा, जरा बता सकते हो? Anyone? बताओ. So that will be zero. There is not any correction because this is antisymmetric. आप जब कोई भी इंटीग्रेशन को करोगे, so what will happen? The mod, this will be contributed the same amount as this particular point, but here it is negative, here it is positive, so it will just cancel out. So you have to just work on this particular thing. Okay. So this is very interesting where you can use the concept of symmetry और बेसिक कॉन्सेप्ट ऑफ इंटीग्रेशन इंटीग्रेशन की प्रॉपर्टी का यूज यहां पर करना बहुत ज्यादा जरूरी होगा जिसमें कि आप इस तरह के प्रॉब्लम्स को कर सको ओके सो दिस इज वन टाइप ऑफ प्रॉब्लम एंड यू हैव टू ऑलवेज do the integration in a very nice way. So here there are again 2 and 3 integration is very important. First, do the integration by parts. Please practice it or revise the integration by parts. And second is gamma integral. So you have to just go for these two integration, and obviously once you do this integration you will be easy to solve this type of problem. Okay, अब बहुत आसानी के साथ इस तरह के प्रॉब्लम को कर सकते हो. And then you have to go for a psi n1. What is psi n1? Psi n1 is equal to m is not equal to n. You have phi m w phi n, and here you have en0 minus em0 and phi m is here. You have to always take care that this m will vary from which is all possible value but not m is equal to n. So you have to always work for this. और इसके ऊपर भी क्वेश्चंस आ सकते हैं. मेनली डिराक डेल्टा फंक्शन जैसे चीज यहाँ पर इंट्रोड्यूस किया जा सकता है. And you have to just go for en2, and the same formula you have em is not, so you have to just go for phi m w phi n, and you have to take mod square, and here you have en0 minus em0. And you also know the some basic property. What is the basic property? So E ground state of second order is always less than or equal to 0. So the ground state of second order energy correction is always negative, or it will be 0. It will be 0 if this matrix element is 0. So this property have came in your exam at least 2 and 3 times. So they will just ask you which one of the following is correct or which one of the following is wrong. So please, student, just try to go for this, and whatever we have done in our class, just try to calculate these all the problem. Just try to revisit all the problem. All are very easy problem. You can directly use there. Okay. So this is very important, and at least one problem will surely came into your exam. So next we will go for a degenerate perturbation. This is all about the non-degenerate. We know non-degenerate. And please do this calculation with yourself. Okay. Please do this calculation for the practice part. And you can take all type of potential. You can, if you are talking about particle in box, go for 0 to a, go for minus a by 2 to plus a by 2, go for minus a to plus a. Then you can have enough practice. Okay. If you have harmonic oscillator, so at least solve each and everything for ground state and for the nth state also. And obviously for harmonic oscillator, x4 is also important. Okay. For the nth state, for the ground state, you can easily use gamma integral and you can solve it. Okay. So next we will talk little bit about the degenerate perturbation. So degenerate perturbation is very easy, but obviously you have to work in a very nice form. So I will just explain this thing with help of problem, because there is not any formula. You have to just go for a problem, and then you can easily revise this particular topic. So what you have to do, the real challenge is you have your H0 and you have lambda W. The real challenge is that you have to write W dash in a basis, and the matrix element of W dash is W dash Mn, and that can be written as Wm Wn. Once you will write this thing, and then you have to find the eigenvalue of W dash, and that will be your correction. So the challenge is that you have to find eigenvalue of W dash. Okay, and that will be the first order correction. So obviously you have to go for this. Suppose you have this type of 0 0 0 E naught 0 0 0 minus E naught, and you have lambda, and that value is equal to, let's say, V naught 0 0 0 V naught V naught 0 V naught V naught. Suppose you have this particular potential. So how you will go for this? कैसे आप इसको करोगे? If, and obviously there is combination of degenerate as well as non-degenerate. So for the non-degenerate, you have to go for what? Non-degenerate perturbation. But for the degenerate, you have to do some little bit manipulation. So what is your phi 1? Your phi 1 is equal to 1 0 0. What is your phi 2? Your phi 2 is equal to 0 1 0. And what is your phi 3? Your phi 3 is equal to 0 0 1. And this is your E naught. This will be your E naught. And this value is equal to what? Minus E naught. Now, the thing is that for the degenerate perturbation, you have to write this matrix in the basis of what? Your W dash matrix. What will be dimension of this W dash matrix? Can you please tell me what will be dimension of this W dash matrix? किसके किसके बेसिस में लिखोगे यहां पर? Anyone? आपका एग्जाम आ रहा है, प्लीज. You have to write your W dash in a, you have to write your W in a basis of which eigenvectors for the degenerate perturbation. हम लोगों ने क्लास में किया है. Anyone?
Original Hamiltonian.
क्या है ओरिजिनल हैमिल्टोनियन? तो के आइगन वैल्यू आइगन वेक्टर तो मैंने लिख लिए. अब मुझे डब्ल्यू डैश लिखना है. किसकी बेसिस में लिखे? प्लीज, किसकी बेसिस में लिखे हैं? फाइव 1 फाइव 2 फाइव 3 या फाइव 1 फाइव 2? किसकी बेसिस में लिखे? माय गुडनेस, 5 1 and 5 2. Because your degeneracy is attached to this particular state and this particular state. So you have to calculate this particular. So you have to calculate W dash 1 1, that is phi 1 W phi 1, W dash 1 2, that is phi 1 W phi 2, W dash 2 1, that is phi 2 W phi 1, and then you have basically W dash 2 2, and that value is equal to phi 2 W phi 2. So the degeneracy is in 2 cross 2 space. So W dash will be also 2 cross 2 space. अगर ये सपोज करो ऐसा लिखा रहता, देन आप W dash किसके बेसिस में लिखते? Then you have to write your W dash in a basis of phi 1 and phi 3. Are you getting my point? बिल्कुल नहीं पढ़ाई कर रहे हो भाई, क्या कर रहे हो? What you people are revising? अभी तो खत्म हुआ ये टॉपिक, जस्ट 10 दिन के पहले. Just go to your copy and do your all problem. Okay, so you have to just go for this particular thing and then you have to solve the problem. So basically, what is the final idea? Idea is that one should write W in basis in which H naught is diagonalized. One should write W in a basis in which H naught is diagonalized and find W dash, the eigenvalue of W dash is first order correction. So eigenvalue will be what? First order correction. And please go and do whatever problem I have given in your copy. We have discussed in your class. We have discussed a lot of problems. Just try to do all these problems. Here we cannot solve each and everything. I am just giving you idea where you have to focus and which type of problem you have to calculate. So this is the basic fundamental. There is not any formula, nothing else. Only concept is that you have to write your W dash, you have to write your W in a basis in which H naught is diagonalized. And you have to very much careful that you have to take only that subspace where degeneracy is there. For example, in this particular original Hamiltonian, degeneracy is associated for phi1 and phi2. So why we are writing W dash in a basis of phi1 and phi2. So this is your degenerate perturbation theory. Please go and revise your copy. And next is what all about the time dependent perturbation. So in the time dependent, they will mainly ask you a transition probability between one state to another state. So what is your formula? किसी को formula याद है? Anyone?
minus I by H cross integral 0 to T.
So you have minus I upon H cut and then
Integral 0 to T.
0 to T, then
Phi F E of R
Huh?
T.
phi f VR phi I,
Phi I.
and you have some ft e to the power I omega naught t dt mod square. So what you have? You have your VRT as a function of VR and ft. You can separate the time part and you can separate the space part. So you have to take this mod square. And what is your omega naught? EF minus EI upon H cut.
H.
So this formula you have to use, and this phi, and this is nothing but the matrix, transition matrix. This is very famously known as what? Transition matrix between I and F state. So initial state to final state. So this formula is very useful and very important for your exam point of view. But this formula can be reduced into two different formula. So we have also done that thing. What is your case one? When your potential is something like VR and cos or sine type of function, and you have omega is nearly equal to omega naught. So then how this is going to change. कैसे change हो रहा है? So this PIF is equal to, so this is pi f VR pi I mod square h cut square, and you have sine square omega naught minus omega t upon 2 upon omega naught minus omega whole square. So this is one formula you have to remember. And case 2, where your potential is not a function of time. So this is also very important. Direct question had came into your exam. So VR is only function of VR. Can anybody tell me what is the formula? और सबसे बड़ी बात है कि मैं तो इसके ऊपर क्वेश्चंस भी बना के दे रहा हूं, प्रीवियस ईयर के क्वेश्चंस, जो कि जिसमें सारे चीज यूज किए हैं. जस्ट टेल मी व्हाट इज योर फॉर्मूला, how this thing is going to change. We have done just before 10 to 15 days, isn't it? 10 दिन पहले ही किया है. What is this particular thing?
4 into.
Yes, that is 4 into pi f VR pi I mod square into omega naught square h cut square, and then you have sine square omega naught t by 2. Okay, and you have this value is sine square omega naught t by 2. That's it. And if your omega t by 2 is very small, you can easily change this particular thing, है ना? इसे भी आप क्या कर सकते हो? Change कर सकते हो. Sin omega t by 2 by sin omega t by 2 is equal to 1. So you can take approximation also. So for this particular thing, they will ask the transition probability, but you have to read question very carefully. What is going to happen at t is equal to 0? What is going to happen at after time t? And according to that, you have to do the transition. So this type of question you have to prepare. We have done in our class. So just go and revise this thing. Okay. Next, we will go for a WKB approximation. फास्ट रिवीजन करना चाहिए, है ना? पता नहीं बैठे रहते हो, ये सब तो बिल्कुल याद होना चाहिए. एग्जाम में अगर फंडामेंटल चीज ही नहीं पता रहेगा तो आगे कैसे करोगे? चलो. नेक्स्ट इज व्हाट? WKB approximation. So in a WKB approximation, the first thing is all about your condition for WKB, that is lambda d lambda upon dx must be less than lambda. So this is your first condition of WKB approximation, isn't it? So your lambda should be, your potential should be very slow varying, है ना? Your potential should be slow varying. So this is your condition for WKB approximation. And then you have to remember 3 type of condition. One is rigid hard potential, rigid or rigid, both are rigid. Another is one rigid and one is smooth, and another is both are smooth. And you have some quantization rule. What is this quantization rule? x1 to x2 is equal to what? N pi h cut, or you can write is n plus 1 pi h cut. What is x1 and x2? Is the turning point. Okay, so this is your turning point. For first one, you have n is equal to 1, 2, 3, and here you can go for n is equal to 0, 1, 2, 3. Okay, and what is your px? your Px is equal to, every time you will just go for Px is equal to root under 2m E minus Vx. So this is your Px and you can easily calculate this thing. For second one, this is rigid and this is smooth. So you have again x1 and x2 and you have Px dx. What is this value? क्या होगा जरा बताओ? N plus 3 by 4 pi h cut. Okay. And for here for n is equal to what? 0, 1, 2, 3. And second is n minus 1 by 4 pi h cut. So both you can remember. So that is 2, 3. Huh? That is 1, 2, 3 and so on. Okay. And next is all about your x1 to x2. You will just go for Px dx. What is this value? N plus half pi h cut. Okay. And how you will get x1 and x2? How you will get x1 and x2? So you will write the expression of energy and that value is Px square upon 2m plus Vx. And for x1 and x2, Px is equal to what? 0. So you will put Px is equal to 0 and you can easily calculate this thing. Obviously, this is your formula. You have to remember this formula. But problem is that how you will solve it. So obviously, when you will go for this integration, just try to, you have to just go for a basic concept. The first concept is, क्या करना है इसको? What is algorithm? Make it, बताओ, dimensionless. So how you will make it dimensionless? You will take root under 2me common and you will go for 1 minus Vx by E dx. So this is, and here you have x1 to x2. And after then, if you are making it dimensionless, then second step, you have to make the provision such that your integration is between 0 to 1. So make a provision, make a substitution. Make a substitution such that integration is between 0 to 1. Okay. For example, suppose I have Vx is equal to kx to the power 4. Then which one of the following will be useful? कौन सा useful होगा? Which one of the following formula is useful? First, second, or third? Third one. Okay, because this is smooth and you have to go for integration. कहां से कहां तक जाओगे? You will write the expression of energy. Energy is equal to nothing but Px square upon 2m plus potential, and this potential is kx to the power 4. And for the turning point, what do you have to do? बताइए क्या होगा turning point?
Px equal to 4.
Px is equal to 0. So x value is equal to what? X की value क्या हो जाएगी? E upon k to the power 1 by 4. So this is your x is E by k. So what do you have to do? You have to go for this type of potential. And if you will go for the phase space, your phase space is something like this. And actually you are calculating the area under the phase space. So you have to just go for this one, isn't it? X1 to X2. So what is your value of X1? Minus E upon K to the power 1 by 4. What is value of X2? E upon K to the power 1 by 4. And your integration will be, you will use the second one. And what is your integration? Your integration will be minus e upon k to the power 1 by 4, e upon k to the power 1 by 4. Your integration is 2m e minus kx to the power 4 dx. So this is your even integration or odd integration. क्या है ये? So this is your even integration. So you will just go for 2 times 0 to e upon k 1 by 4, and you have 2m e minus kx to the power 4 dx. So what will be your next substitution? And that value is equal to what? N plus half pi h cut. Okay. What will be your next substitution? क्या करोगे बताओ? How you will do this integration? सारा किया हुआ है बहुत बार, एक बार दो बार नहीं, बहुत बार. You will just take 2 into root under 2me common, and your integration is 0 to e upon k to the power 1 by 4, and you have 1 minus k upon e x4 dx. What will be your substitution such that you will go from 0 to 1? क्या substitute करोगे? Anyone? बताइए, what is your substitution? सारा सिखा चुका हूं, है ना? लेकिन फिर भी आप नहीं बता रहे हो. The substitution is all about e upon k to the power 1 by 4 into x is equal to t. And once you will do this substitution, you will get this integration is 2 into root under 2me into e by k to the power 1 by 4, and you have integration 1 minus t to the power 4 dt 0 to 1. And now you can do this integration, and even you will not do this integration, this value is obviously between 0 to 1, and you have make this is dimensionless, and you know this is e to the power half and e to the power 4 is there, and that value is equal to n plus half pi h cut. So this type of calculation you have to do, and you have to very much careful for the parameter also, because into last to last examination they will ask for this type of problem with the help of parameters. Means lambda को 2 lambda कर दिया, k को 2k कर दिया, k को double कर दिया, then how your energy is going to change. So you have to learn this particular method, how you can make it dimensionless. So this is the only thing you have to work. And one more thing you have to go for this, that is what? Tunneling probability. So what is your tunneling probability? Anyone? E to the power minus 2 gamma. That is your tunneling probability. What is value of gamma? And tunneling will be possible if E is less than Vx. So what is your gamma?
1 by h cut.
1 upon h cut, and you will tunnel between two turning point x1 and x2, and that value is 2m. Here you will go for what? Vx minus e, isn't it? Dx. Okay. And once you will calculate it, you can get this particular tunneling probability. So इसके ऊपर भी questions आपके एग्जाम में आ सकते हैं. So please prepare it very nicely. Okay. Now we will go for a last part, that is your variational principle. So when you will go for variational principle, obviously you have to find the average value of energy, and that is nothing but average value of kinetic energy, average value of potential energy. Here your E will be function of alpha, and you have to find the average value of kinetic energy and the potential energy on some trial wave function, and that will be function of x and alpha. So you have to find this thing on a basis on this particular trial wave function. Any trial wave function, the examiner will give you trial wave function. On that basis, you have to calculate. And once you will calculate this particular thing, E alpha, you have to go for dE alpha upon D alpha must be 0 at some alpha is equal to alpha naught, and this alpha naught is assumed to be the minima of energy. So this is alpha is equal to alpha naught, u has greater than 0. And finally, what you have to do, you have to calculate E alpha naught. So this is all about your basic thing you have to always remember. But sometime you have to also check your answer. What is the relationship between kinetic energy and potential energy with the use of virial theorem? So what is your virial theorem? If your potential is VR and that value is equal to is k r to the power n, where k is constant, n is some number, and then your kinetic energy, the average of kinetic energy is n by 2 average of potential energy. So whenever you are doing this calculation, always try to check whether you are getting or not. For example, for harmonic oscillator, n is equal to 2. So then average of kinetic energy is equal to average of potential energy. For hydrogen atom, n is equal to -1. So you can have average of kinetic energy, negative of average of potential energy, negative of half of average of potential energy. So this is very important to recheck your answer. And I have just told you what are the basic algorithm that you have to solve it. You have to just follow into your examination. And best thing is that you have to prepare a kinetic energy for different type of wave function, mainly for the Gaussian, the Dirac delta. Suppose this is your 2 alpha upon pi to the power 1 by 4 e to the power minus alpha x square. What is your kinetic energy? You remember all this thing? What is your kinetic energy?
H cross square, H cut square alpha by 2n.
Alpha by 2n. Again, suppose your psi x is equal to, you have root alpha e to the power minus alpha mod x. What is your kinetic energy?
Same, sir.
Same. H cut square alpha square by 2m. Okay. Just go to your copy at least, isn't it? अपनी कॉपी में तो जाकर तो देखो, नहीं?
Yes, sir. Yes, sir. Alpha square.
And suppose your psi x is something 128 alpha cube upon pi to the power 1 by 4 x e to the power minus alpha x square, and this is for x is greater than 0 and 0. What is your kinetic energy, average of kinetic energy? 3 h cut square alpha upon 2m. Okay, and again you have to also remember some more wave function. Obviously you can do it in the examination also, but it is much better that for some basic wave function you have to remember all this thing. Okay, sorry, this will be x e to the power minus alpha x square. Okay, suppose your psi x is equal to root 2 by 2a cos pi x by 2a, where x is between minus a to plus a. What will be kinetic energy? And 0 otherwise. What will be kinetic energy? pi
square
square
h square square
upon 2m
2ma.
ma square, not this is 2a square. मैंने कितनी बार बोला है कि ध्यान से देखो, this is between -a to +a, the width is 2a, isn't it? अगर ये -a/2 to +a/2 रहता तो pi x by a होता और यहाँ पर 2/a होता. You can see this particular thing. The boundary is very
Yes.
important. Don't just mug up. Recall the thing. And last, this is very important. And this is basically your root 15 upon 16 a to the power 5 x a minus x, where x is between 0 to a. Sorry, this is not the thing. This will be a square minus x square, where x is between -a to +a and 0 otherwise. What will be kinetic energy?
5 h class square by 4ma.
Very good. So that value is equal to 5. So the kinetic energy is equal to 5 h cut square by 4 ma square. So you have to at least remember all this thing. एक और practice कर लेना आप. That is x a minus x. उसके लिए kinetic energy क्या? But that is easy. You can easily calculate this thing. So this type of wave function can came as a trial wave function, and then you have to go for just maxima and minima, find the value of alpha naught, and then you can get this particular energy. बहुत सालों से variational principle से कोई भी problem नहीं आया है. So please try to do practice on this one. Maybe this year this type of problem can come into your exam. So this is from my side of revision of all quantum mechanics. And if you want to revise the relativistic quantum mechanics, go for my video, but because that is itself a very compact thing. But in general, if you are going to focus on these area, I think you are able to, you are just going to attempt us all questions. Okay. So, okay, all the best. Thank you.
Thank you.